There are 5 types of Platonic solids we will look at in this video. A Platonic solid is a regular, convex polyhedron. It is constructed by congruent, identical in shape and size, regular, all angles equal and all sides equal, polygonal faces with the same number of faces meeting at each vertex. In simple terms, if you look at a Platonic shape, you will notice it has the same geometric shape all around it. There are 5 types of Platonic solids. There are 3 things you should know about each Platonic solid. Faces. Edges. Vertex. Faces. This is the flat parts of each shape.
This is the part where the flat parts meet, as indicated by the yellow markings on the diagram. Thereafter we have the vertex. The vertex is the pointed corners of each Platonic solid, and I've indicated it by the red markings to show you the corners. What is important for the exam purposes is that we know how many faces, edges and vertices are on each particular Platonic solid, and we will take a look at that now shortly. The tetrahedron has 4 faces, 6 edges and 4 vertices. Secondly, the cube has 6 faces, 12 edges and 8 vertices. The octahedron has 8 faces, 12 edges and 6 vertices. The dodecahedron has 12 faces, 30 edges and 20 vertices. The ICOSAHEDRON has 20 faces, 30 edges and 12 vertices. Now that we have learnt the properties of each of these Platonic solids in terms of faces, edges and vertices, there is a way in which we can check our answers in order to find out whether we have the correct amount of faces, vertices or edges for the particular Platonic solid we are talking about. This is where we are introduced to what is known as Euler's formula, and it is basically faces plus vertices minus the edges, and it will always give you an answer of 2. If in the event you don't get an answer of 2, then you know that you are not using the correct amount of faces, vertices or edges for your particular shape that you're talking about. If we are to consider the cube for the Euler's formula, it will be faces plus vertices minus edges is equal to 2, and if we substitute this into the formula for Euler's, it will be 6 faces plus 8 vertices minus 12 edges. These are the properties for a cube, and we'll find that the answer will be 2. If you have to do this for all the other Platonic solids, each one of them according to their properties, you'd find that they all will give you an answer of 2. And I did not want to put the remaining Platonic solids up. This will be something nice for you to do as an exercise to see if you arrive at the amount 2. Thanks for watching and see you in our next video.